All right, everyone. It's time for our last Khan Academy unit test so far for these first 2 weeks. And so what we're going to do now is look at the bivariate numerical data assignment. So this one has you measuring the correlation coefficient for these 4 scatter plots. And one thing you want to realize is that 2 of these are positive, 2 of these are negative, and the values are just a little bit different. One thing to remember about the correlation coefficient R is that it's supposed to be measuring the strength of a linear relationship. And so if it's positive and close to 1, that means it's a strong positive linear relationship. If it's negative and closer to -1, that means it's a strong negative linear relationship. Typically, we say it's strong if it's greater than 0.75, and that's absolute value. So in other words, if it's negative 0.75 or more, that's considered strong. If it's in between negative 0.25 and negative 0.75, it's considered moderate. Same thing, positive 0.25, positive 0.75. And then anything between negative 0.25 and positive 0.25 is weak. So anyways, we can look at scattered plot B first and notice that that one has the most clear positive relationship out of all of these. And what I mean by most clear or most strong is the fact that they're all closely gathered together. Whereas this one is the only other positive relationship I kind of see, but everything's a little bit more spread out. So in other words, B has the strongest linear relationship, and C has the moderate linear relationship. From there, when we look at A and D, that must mean that A is negative, although A almost looks like nothing's going on. So D must be the one that's a stronger negative. So D should be the larger negative value, which it is just based on how it was. And yeah, so C is a low, moderate, almost a weak linear relationship, and that's why it almost looks like nothing. All right, when we look at this question, we're supposed to be interpreting the residual. And so what we can see here is that the actual data point is lower than the predicted line. And so what that means is this customer's prescribed dosage in actuality is 50 milligrams lower than the predicted value based on their mass. When you look through the other choices, they say this customer has a mass of 50 kilograms greater. That's not true. It's their mass, and that predicts the dosage. And the question is, how different is the dosage amount based on the mass? All right, and now we're interpreting slope, and you can read through all of it, but essentially it says the fitted line has a slope of 8.42. What's the best interpretation? And the general interpretation for slope is for every 1 unit increase in the explanatory variable, there is a slope unit either increase or decrease, whether it's positive or negative, in the response variable. So one thing that's nice to look at is this chart. The explanatory variable is on the bottom, and the response variable is going to be on the right. In other words, the explanatory is the x-axis. That's how you want to think about it. Explanatory, x. So for every 1 unit increase in salary, explanatory, there should be an 8.42 point increase in winning percentage. That's the correct interpretation. For every 1 unit increase in the explanatory, there's a slope increase, since it's positive, in the response. All right. Up next, it says which statement best describes the association between these variables. And we can see there's a positive association. What that really means is as one variable increases, so does the other. So as your income increases, your bedroom rent increases as well. So how can we interpret this? Cities with higher incomes tended to have higher rents. That's what we can interpret from this. All right. Up next, it's a little bit small here, but this dot right here is bigger than the others, and they're considering removing this outlier from the data set. The reason this is called an outlier is because of the vertical distance from the trend line, not the horizontal distance. It's only how far vertically is it from the trend line, and you can see this one is farther than any other. Now, if we were to remove this point, essentially, let me give you a picture of before and after. Before, the line's going to be something like this. And you can see that there's like a few data points above, one pretty much on, and the rest are kind of in between. When we remove this outlier down here, what you're going to end up seeing is, if I were to draw this exactly the same, it's now going to look like this. In other words, it's going to tilt just that much this way. It's going to tilt like that. Maybe I should do it with this pencil. So it's going to go from here to maybe about there. And when you look at that, here's what that means. Will r squared increase? Yes, because that is a way of measuring the strength of the relationship as well. That is r going to be closer to -1? That's also true, because again, there is a negative slope, and it's the fact that this line is now going to fit those points more closely, so the strength will increase. And will the slope increase? The slope is actually going to get more negative, so that would actually be a decrease. All right, up next, we're just looking at the what we call the computer output, and we're forming the equation. Remember that this is your y-intercept, and this is your slope, and this is also telling you what the explanatory variable is. So in other words, remember explanatory is x. The regression line is intercept plus slope times x. Now, the value of the y-intercept is just right here, the first thing in coefficient column for constant. That's your y-intercept, because the y-intercept never changes, it remains constant. And then from there, the slope is right underneath. And again, price is the explanatory variable, so we should choose the answer that says y-intercept plus the slope times the explanatory variable. Up next, we're supposed to be choosing the residual plot for the data. Now, the residual plot is essentially the plot of the vertical distances from the actual data points to the trend line. And so the idea is the way we calculate a residual is always actual minus predicted. In other words, AP. So the actual value is above the trend line, which means it's larger, so this should be a positive residual. And so far, just by looking at it, A seems to be pretty convincing. And yeah, it is A. You can see that the vertical distance in A, it almost has that same shape to it. And then one other way you can interpret it is there's one almost on the line, a little bit further, and that reads that way. So does B, but C definitely does not. And then from there it goes above, 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 and then below. And so we see above, 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 and then below. All right, up next we have a scatter plot here, and they want to know which one displays the data best. And what you're looking for in this scenario is that the explanatory variable is on the x-axis and that the data is pretty visible through the entire graph. There's no wasted space. So what I mean by that is C and D are definitely out because they have all this wasted space. The question is, what's the explanatory variable, and is it on the x-axis on the bottom? And so we're supposed to predict how much fuel in our car is used based on speed. And so since we say based on speed, speed is the explanatory variable, so A is the correct answer. That's the one that has speed as the x-axis, and there's not much wasted space. All right, up next what we're looking at is describing the relationship we see in this scattered plot here. What you're supposed to do in this case is you're supposed to address what we call the form, the strength, and the direction, as well as mentioning outliers. So form would be nonlinear, and they did say that. Strength, well, they did say strong, so there we go. And then also direction, did they say positive or negative? And the idea is, as you read from left to right, it's decreasing, so they should have mentioned negative, and they didn't. They also mentioned that there aren't any outliers, which is good as well. So they forgot to talk about the direction. They didn't mention that it's decreasing. All right, up next, when you look at this, there does appear to be a negative association, and there does appear to be a linear association. Although this point right here would probably be considered an outlier. All right, last but not least, we're supposed to create the equation of our regression line. And when you do that, to find the slope, the value that goes next to x, what you do, call this b, the formula for that is r times s of y times s of x. So we have all three of those. So we have negative 0.98 times 30.8 divided by 2.8. And let's see what that is. We get negative 10.78. Now from there, we're supposed to find the y-intercept value. And there's a little bit of a trick to this because when you look at your stat reference sheet, it writes it like this. But the y-intercept itself is a. So in other words, what you need is you need a, so you need to find the average of y minus b times the average of x. And the other key there is you just solved for b up above. So the average for y is 37.6 minus the negative 10.78 times the average for x, which is 10.2. So we have 37.6 minus negative 10.78 times 10.2. Oops. And we get 147.556. The last question is, what do they want us to round to? And the answer is the hundredth. So that slope is good. We'll just write negative 10.78. But the y-intercept we're going to have to round ever so slightly, and that'll be 147.56. And there we go.